This is chapter 2 of PO2, 2.3 and 2.4. In this lesson, we'll look into composite and inverse function. We'll look into the relationship between composite and inverse function, and also look into domain and the range about these two functions. Right, so some notes. Let's start with composite function. Start with the basics. First of all, we know f of g of x, it means we apply g first and then f. So algebraically, we substitute g of x into f of x. Right? The domain and range of any composite function are found directly from the composite function itself. So that means if you want to find domain and range of a composite function, you have to find the function itself first. So you have to find the composite function and then work out from there. So below, there are some starter questions about basic stuff about composite function. So pause the video, have a go at the question. If you need help, you can play the video and I'll go for the answers. Right, so the first one, the functions f and g are defined by f of x equals da, da, da. Find the function of f of g of x. That means you replace g of x into f of x. So this one, f of g of x, means whenever you see x in the f, the g of x will go into it. So that means this will go into the x in here. So it'll be 3 bracket x squared plus 4 plus 2. You can expand it, but that's not the point of it. I just want to make sure you know which one substitute into which one. This one, g of f of x, means you substitute f of x into g of x. So this time we'll replace f of x into the x in here. So which equal x squared, so 3x plus 2 squared plus 4. Now f2x, it means f of x. It means you replace f of x into f of x. So 3 bracket 3x plus 2 plus 2. Part D, find the value of b such that f of g of b equals 62. F of g of b is the same as the first question, so we will replace x as b. So 3 bracket b squared plus 4 plus 2 equals 62. The different ways you can solve it, what I'll do is I'll bring the 2 over to becomes a minus. So 3 bracket b squared plus 4 equals 60. 3 times something to reverse it, that means divide. So b squared plus 4 equals 20. B equals plus or minus 4. Okay. Because minus it, 16 square root 16 plus or minus 4. That's why it says values. Right, next one. Example. The functions f and g are defined by f of x equals to modulus of 2x minus 8. If you remember what modulus means, modulus turns everything negative to positive. G of x equals x plus 1 over 2. Find f of g of 3. In here, what I'll do is I can find g of 3 first. So g of 3 is 3 plus 1 over 2, which is 2. So f of g of 3 means same as f of 2 equals to modulus 2 times 2 minus 8, which is modulus of minus 4, which is just 4. Part B, solve f of g of x equals x. Now, this time we have no choice but to do it algebraically. We have to replace substitute g of x into f of x. So I'm going to keep the structure of f of x, but when I see x, I replace it with g of x. So that equals to modulus 2 and the 2 cancel out. So x plus 1 minus 8, that will become x minus 7. And we know modulus of x minus 7 equals x because we're asked to equate to x. If you remember from 2.1, to solve an equation with modulus, we have to consider 2 cases where one is inside is positive and the other one you've put a negative bracket outside of it. So this one, now this is a funky one because when you do x minus 7 equal x, when you try to do x in here, it doesn't work. That means there's no solution in here. Because if you try to do the x, you get 0 equals 7. So there's no solution. This one, x squared bracket minus x plus 7 equals x, 2x equals 7, x equals 3.5, and that's the answer. Let's carry on. So I took a question from the textbook, practice 2, exercise 2C, question 9. Let's have a look. I deliberately chose this question is because I know a lot of students are probably not too confident in ln, in logarithms, and in e. That's why I wanted to choose this one to go through with you. Question 9, the functions p and q are defined by p of x equals ln x plus 3. And for qx equals e to the power of 3x minus 1. Find q of p of x and say its range. So let's go. So q of p of x means we substitute p of x into q of x. So we are keeping the structure of q, so e to the power of 3, but whenever we see x, we replace it with p, ln x plus 3 minus 1. Next, if I want to cancel e and ln, I need to somehow put the 3 elsewhere. Now, using log rules, I know I can put a 3 into the power of x plus 3. So e to the power of ln x plus 3 cubed minus 1, e and ln, and now cancel out. So x plus 3 cubed minus 1 is the function. Find its range. To find its range, we can draw a graph to help us. Now, this is a cubic graph. Now, if you've got the graph calculator, you can put it in. Just be mindful, x has to be greater than minus 3 because of the because of the p. Right, so now, just a sketch. I know x cubed graph looks like this. That's x cubed graph. So if I do x plus 3 cubed, plus 3 means move to left by 3, so left by 3 and down by 1. So graph will look like, no, actually, this bit is minus 3, move down by 1. Yeah, and this one is minus 1. So that's the graph. Right, I want x has to be greater than minus 3. So when x equals to minus 3, then the qp of x equals to minus 3 plus 3 cubed minus 1. That's minus 1. So what they try to say here is x has to be greater than minus 3. Oh, actually, minus 3 is there, so I don't need to know this. X has to be greater than minus 3. That means we are only taking the part of the graph where x is greater than minus 3. So this is the point where x is minus 3. X greater than minus 3 means this part of the graph. Okay, so the range. So if you look at the range, so we know that part of the graph is what we need. The range is the y-axis. The minimum point is here, minus 1, and it go up and up and up forever. So therefore, the range is y greater than minus 1, greater or equal to minus 1. Part B, find the range, find the value of QP of 7. So part B, QP of 7. So QP of 7 means replace that by 7. So 7 plus 3 cubed minus 1. 10 cubed is 1,000. Minus 1 is 999. Part C, solve Q of P of C equals 124. Easy peasy. X plus 3 cubed minus 1 equals 124. Add 1, cube root. Now, when you cube root, there's no plus and minus. Okay, when you cube root, there's no plus and minus. So, so x equals minus it, x equals 2. Right, so next one. So next, we move on to inverse function. Okay, so inverse function, well, a couple of things to say, and it's an exam favorite. Compared to composite function, it's like, you know, between siblings, there's always one favorite from a parent. They'll never admit it, but there's always one. In exam parent, the inverse function is a favorite child. Right, so first of all, the inverse function of f of x is the symbol is the -1 on top, inverse. So, but what's the definition then? Such that the definition is if you do f of inverse or the inverse f of inverse of f of x, you always get back just the x. That means f sort of the function itself cancel each other and the answer will be x. The graph, you need to know the graph of f of x and f of inverse are reflections of each other in the line of y equals x. So if I got a really funky equation that I can't do, for example, f of inverse, which I can't draw it, I can use the f of x graph to help me draw it because I can draw the original and reflect it. For example, in here, let's say we have our famous one is e to the power of x. Let's draw that. Now, you should all know that's the graph of e to the power of x. Let's say that's f of x of e to the power of x. Now, the inverse of e to the power of x is ln. So f of x is e to the power of x. Inverse is ln x. Now, if you remember ln x graph, it actually looks like this. Now, why is that the case? Actually, let me use a different color. I like green. The reason that is because there is the line y equals x in there, reflected. So that's the line y equals x. This is the f of inverse of x, which is ln x. Okay, so if you don't know how to draw, let's say the inverse, you can draw the original and reflect in the line y equals x. Now, because of the line y equals x, what it means is when you reflect in the line y equals x, the x value that was in the original function becomes the y value of the new one. Pair it up with domain and range. If you have the, let's say, f of x in here, if you have f of x, inverse of f of x, the domain and the range, domain and the range. Now, the x value of the original becomes the y value of the inverse. It means the domain of the original becomes the range of the inverse and vice versa. And the range of the original becomes the domain of the inverse and vice versa. So we can write here, so domain of f of x equals the range of inverse. And the range of the original equals the domain of the inverse. Now that is very, very, very important. Very important. Very, very important. Okay, so make sure you remember that. Right. Moving on, let's look at example. Example, the function f of x equal to square root of x minus 2. Now remember that originally that would be a one-to-many graph, because if you remember the square root x graph looks like this, right? Remember that. And we talk about there's a one-to-many, which is not a mapping function. But because they specify x has be greater equals to 2, well, actually, they put a positive actually. You know what I said. It doesn't apply in here. Anyway, state the range of f of x. So what is the range of f of x? Now here, what I can. So we can use the help of the graph. So now you know the square root of x graph looks like this, right? So that's a root x graph. Now when you have root x minus 2, the minus 2 is inside the x. That means you're moving the graph to the right by 2. Okay, so moving the graph to the right by 2 looks like this, and that's 2. Right, so and what's the range then? Now the range is about the y-axis. So if you look at the y-axis, we've got values in here. We've got values going up and up and up, and we've also got the values down and down and down. So they'll be more negative. So as the number of x gets bigger and bigger, you can see there are always values of y. Because imagine if it's something very big numbers of x, you get very big numbers and y and very small number and very negative values of y. Because imagine you put x equals 1,000,000. When you square root 1,000,000, you get plus and minus. So how do we wrap up the range for all values then? So the range, therefore, the range, we call it f of x, belongs to all real numbers. Okay, so if it includes everything, then we say f of x belongs to all real numbers. That's how we write the range. Part B. Find the function f of, okay, so find the inverse function first. To find the inverse function, we'll make y equals square root x minus 2. And then we try and make x a subject in here. So we're trying to make x a subject. So next day we're going to make x a subject. So y squared equals x minus 2. So y squared plus 2 equals x. So that's the first step. Next step, you replace x with inverse. So our final answer would therefore be the inverse of x equals x squared plus 2. Now find the domain and range. Remember that graph I showed you about the inverse domain range. They are like this kind of relationship. So we found the range of the original. That means we can find domain. So domain of inverse, the domain of inverse is therefore x belongs to all real numbers. So the range that we found in part A becomes the domain. And to find the range of the inverse, we can use the domain of the original. What's the domain? Where's the domain of the original? The domain of original is actually hidden in the question. That's x squared equals to 2. That's the domain. So therefore, the range of, I don't mean to write in red, and it actually annoys me, so I'm going to rewrite that in blue. So the range of inverse is, it was x greater equals to 2, now it becomes y greater equals to 2. So that's the range of the inverse. Therefore, I told you it's quite important to remember the relationship between domain and range of their normal function and inverse function. Sketch a graph of y equals f of x and the graph of inverse and the line y equals x. Now we've done the original graph. So we know it's like a parabola, but sideways. So that's the f of x. So the x equals to 2. And line y equals x like this. So where's the inverse graph? Then the inverse graph, if you look at the equation, x squared plus 2 means move the graph up by 2. So it'll be like this. That's 2. That's 2. And that's the f of the inverse of x. And that's the answer. Okay. Right. So here's a practice. And then the 2.5. So here's a practice. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, so part A, to find the inverse. So y equals x squared minus 3. So y plus 3 equals x squared, square root. So plus and minus. So, but because x has to be 0, so we don't have to do plus minus. So square root of y plus 3 equals x. So the inverse is therefore square root of x plus 3. Part B, sketch the graph of the inverse graph and state its domain. Well, we can use the original graph, x squared minus 3 to help us. X squared minus 3 means the graph looks like this, because moving down, we're moving the x squared graph down by 3. And then, but because x has to be greater equal 0, therefore we cannot draw this part in. So what happened is the graph looks like this, minus 3. Okay. But that's the y equals f of x. To sketch a graph of inverse, remember we have to draw the line of y equals x, and that looks like this. So therefore, the inverse graph looks like this. It might be a bit too steep. Let me try again. So the inverse graph looks like this. Right, so that's that. And that will be -3, and that's the inverse graph. And domain. So what's domain? The domain of the inverse, the domain, look at the x-axis. So the graph starts from here and all the way there. So, and in the positive x direction, so domain is x greater or equal to -3. Part C, solve the equation where f of x equals f of inverse of x. So x squared -3 equals square root of x plus 3. Square on both sides. So x squared -3, x squared -3 equals x plus 3. So x to the power of 4 minus 3x squared minus 3x squared plus 9 equals x plus 3. A quarter equation, I don't think you have to learn how to solve a quarter equation. Oh, actually, when f of x equals, because x, now what you realize in here is a very difficult equation to solve. Without calculator, it's not possible to solve. So what we could do is, now when f of x equals f of inverse of x, graphically, where do they cross? They cross at the line where y equals x as well. So what we can do is, we can replace y, we can use y equals x and the f of x function to help us to work out the equation. Because yes, f of x, when f of x equals inverse of f of x, they cross at the line y equals x. So we essentially have three equations to work with, actually. So we got y equals x squared minus 3. We got y equals x, and we got y equals square root of x plus 3. So we're not going to use the last one. Let's use the top two. If I replace y as x, so I got x equals x squared minus 3. So 0 equals x squared minus x minus 3. Put in the calculator, and x equals to, so x equals 1 plus or minus root 13 over 2. And that's the answer. Well, actually, you can't use a minus because you can see it only crosses the positive. So therefore, we can't have that. So x equals 1 plus root 13 over 2, not the minus. And I believe that's the end of chapter 2.3 and 2.4.